This video is sponsored by JLC MC.
It's time for me to start building the drawers for my storage room. I have some experience now that I've built 16 of these trolleys, but the next job is a bit bigger. I'm gonna build 56 drawers, 7 rows above the trolleys. I have decided on the material. It's popple plywood, 12 millimeters, or thinner if that's possible. And I have bought a lot of drawer slides from today's sponsor JLC MC. But I have a dilemma. I'm not really sure how to build these drawers optimally. I have 2 important criteria. Since I'm building 56 of them and each of the rows are different, it's a bit limited how much I can mass produce them. They need to be tailor-made, one-on-one almost. So I want to simplify the build, not making it too complex. But on the other hand, I want to make it strong and durable. So I don't want to simplify it too much, so it's getting weak. And I have narrowed it down to 2 designs on how to build them. And I might need your help to decide on what of them to choose. So I will make some prototypes in this video, test out the strength and see what might be the best way to build them. But first, let me show you the drawer slides. And if you haven't heard about JLC MC, you should really check them out. I got a link in the description to this video, even with some discount codes that you can benefit from. They offer 2 important things: quality products to affordable prices. It's just up my alley. For instance, these drawer slides that I have bought, actually bought quite a big bunch of them, 250 kilos of drawer slides. In other words, the shipping did cost almost the same as the products to get them here to Norway, at least including import duties and VAT. Anyway, if I was to buy similar products like this here in Norway, it will cost me at least the double, maybe 4 times as much as the total cost for me. So I saved a lot. And actually, it was not easy to find so many different drawer slides of the same type, heavy-duty products as well. The smallest ones here are rated to 200 kilos per pair, while the biggest ones goes down to 50 kilos per pair, because when you extract them, of course, the weight will be, you know how this works. And when it comes to the size, the bottom ones are 1 meter. I will actually start with a drawer almost 1 meter and 20, and then a 1 meter, 80 centimeters, 60, 50, 40, 30. One thing that was very important for me was that these drawer slides was these 3-type track systems. That means they are made out of 3 parts, and when they are fully extended, you can see that each of the tracks has quite a big overlap, making them very sturdy and very strong, and it makes it so that the drawer can be fully extended. So this is the 30 centimeter drawer slides. So when it's put inside the cabinet, it's hidden, of course, and when you pull it out, it will be fully extended, so you get access into the drawer. These 2 track types, a bit cheaper types, they would normally just extend like this, halfway out, maybe a bit more, and they are normally a bit more flimsy as well, because if you extend more than the half of the width, then they will start to get wiggly. But none of this came as a surprise to me. All of this is well documented on JLC MC's website. Takes maybe a tiny bit of time to understand all the measurements, all the sizes and the numbers. Spend some few minutes there and you can really be sure to buy the correct products. And you get all the dimensions laid out, even 3D model displaying how the products look like, if you want to really dive into them before you buy them. So I can highly recommend JLC MC. They have a lot of different kind of products, mechanical, mechatronical parts. Go to their website and give them a try. So everything is just great then, isn't it? Well, with these drawer slides, I found one irritating issue. if I turn them around, then you will see the mounting I have into the cabinet part, or to the stands in my system where these will be mounted. By the way, I could say when I fully extend these drawer slides, there is a little knob here and I can take this out. So this part is the one that goes on the drawer, and then when the drawer is made and the slides are put in the cabinet, and then they are put on, and they even have a locking mechanism so they stay into place. Anyway, look at this. This is the front part of my storage system. This is the bottom drawer, and then I have my slope ceiling, and I have a beam going here, and I have a stand going here. So I hope I can connect these drawer slides at each end, but then I would need some extra stands, at least for the longest drawers, to have a better support for them. And then I wish these holes for mounting them was in a straight line. It would be much easier if I had a wall, of course, a cabinet wall to mount them to, but I don't have that. So maybe if I drill a hole here, I can have one stand to support at least these 4 longest ones. And then I can have these 2. Let's see how that goes. Maybe it's just my system that is a bit strange. The ones who have designed this, if you want to please me next time, make them the holes in parallel. But this video was not supposed to be about the drawer slides. It was about the drawers. So let me just take these away. I have already prepared material for 2 prototypes. The simple drawer, the complex drawer. Maybe the weak one, maybe the stronger one. Not sure, let's figure out. The simple one is really simple. I just need to cut out the bottom and make it 12 millimeters smaller than it's supposed to be on each side. This is the front piece. Then I have a side piece, another side piece, and the rear piece. Goes like this. Can't be much simpler than this, can it? The drawer slides will then be attached to each side, so it's the side wall that will be holding the weight, and I will use glue and nails, so this will be glued on with nails to support it. This is just super simple. And yeah, I will build this, test it, see how strong it is. I don't want the bottom plate to be pushed out if I put something heavy here. So it all depends on how strong is the glue. Then comes the complex one. And this one looks the same, but it's not. I have made a cutout here. This is a mistake. Pretend this is not there. So after cutting out the bottom plate, I also made sure to make this cutout. Then I did the same on all these pieces. I made a cutout that fits into, or a groove, maybe I should call it. And this now makes these go into each other. I get more surface area for the glue, and the bottom is just holds better into place because of this groove. Even not gluing this, I can feel it's already rigid. So this one feels a lot more sturdy. While this one, so my hunch is I'm gonna build this one. It feels just so much better. But the challenge is it takes twice as long time to cut out the pieces. The gluing and the assembly will be the same, but the cutting part takes longer time. And it's a bit harder to get the precise cut, because I don't have two professional tools. So getting these grooves exactly in the right depth, it's not that easy. So getting the correct dimension can be a bit more challenging. It requires me just to be more precise, spend more time when I'm building them. But then again, maybe this is strong enough. With my glue and the nails, maybe I don't need it to be any stronger. Maximum, I would say 20 to 40 kilos. I can't imagine I'm going to put more weight into them than that. Most of them will just be some kilos. So do I really need this strength? And when you look at them, you can't really see any difference. I just know the difference is there. It has been a few days. I had my drawers to dry upstairs in my heated workshop, so the glue is properly dry now. Prepared to do the testing, the strength test. But before I start, I must mention one thing. A bit of a surprise, for me at least, when I was gluing this. I noticed that the ones with the cutout, with the groove, was much easier to assemble. The pieces, of course, just fit into the grooves. Easier to apply the glue, and a lot less mess on the one that was just edge towards edge, or what to say. It was much more glue that was messing around, and it took a bit more time to align them. And I can actually see that the front piece should have been bit lower down. That's so, yeah, I would say maybe I can save a minute or two on the assembly part by using the grooved version, but I would assume it takes 10 minutes more to make all the cuts. So anyway, in total it will be more time consuming to build the grooved ones. Can I call it that? Yeah, the grooved ones, while the non-grooved ones will be easier to build. But the testing part, I have prepared some wooden pieces here that should simulate the drawer slides. I have an idea on how to test them. Not fully thought out yet, but at least step one is to attach these wooden pieces as drawer slides. My proper heavy-duty drawer slides are recommended to use M5 5mm screws. I have M4 on this test. That will do good enough. And just like that, the first drawer is prepared for strength test. And my neighbor dropped by. Sivert, do you want to check it out? Not very interested. Hard to get help these days. it's time for me to explain how I'm going to do the test. I use my bathroom scale here to just measure the weight I will be putting on. I could, of course, put on this and test it, but whenever it breaks, or if it breaks, then maybe I will damage my scale. So what I really need the scale for is just to measure the weight. For instance, I have this anvil, and when I put it on here, it's not always starting. It's 10 kilos, this anvil. I measured this as well. This is also a bit more than 10 kilos. And I can put on both of these, then I have 20 kilos. Then I will just measure more stuff and put on more and more weight. So these side pieces here now, they makes it so that the bottom is not in contact with the floor. So I just need to put on weight here now. That is a bit difficult because they are so small. That's why I also made this piece. It's just a wooden piece I can put on here. I'm pretty sure 10 kilos should go very easy. So let me just test it straight away. No problem at all, as I suspected. So let me instead put on my toolbox here. It's a bit more than 10 kilos. 12. And then the anvil on top. No issues at all. Not even a cracking sound, nothing. I'm pretty sure I could step up to 40, still nothing happens. So I think the next will be 80 kilos. So I need to find something that weighs 80 kilos. Let's check it. It's a bit of a step though, from 20 to 80s. Let's see how this goes. No problems either. Okay, so 80 kilos works fine. Let me try the complex one, the one I think is even stronger, but I really don't know. Maybe this cutout I made it thinner at the edge. Maybe that just weakens it. I think I'll test 80 kilos straight away. The complex model. Not a sound. That is no problem. So both of these designs can hold 80 kilos. And I'll probably never have 80 kilos in the drawers. But I really want to figure out what is strongest. I want to test it more until it breaks. So I have an idea how to do it. Is this a good idea? I'm not really sure. The idea now is to use this as an anchor to my wall, and then use this as a lever and a weight arm. By putting this on now, it reads already 20 kilos. If I'm standing on top of there, I should transfer my weight directly down to it, and the further I stand here, I will add a lot more weight. So I'll try to see. I'm not sure how far my scale here can go, but let me see what happens if I'm balancing here now. I'm not sure what happened. It says STP. Is that short for stop? Does it mean already too heavy? Let me try it once more. All right, now it works. It already said 130 kilos. I'll try to move further outwards and see the weight. Unfortunately, I only got STP stop message trying to move outwards on the weight bar, so I just have to test it, don't I? I don't know the weight now, but at least I can see how far I can go. And I don't think I need to go very far before I'm adding several hundred kilos. So, testing the simple build first. The one I maybe think it's the weakest one. Hopefully we can hear some kind of crack if I manage to destroy it. What I think, I'll put my microphone close to the floor so it's easier to hear. Okay. That was a failure. Or it was actually a success. I didn't manage to break the drawer, so it can cope with quite a lot of kilos. But I wanted to break it to see which of the versions that breaks first. So I have still the simple design drawer now for testing. I made some modifications. You could hear some crackling noises. It was mostly the plywood, I think, that got some cracks in it because the weight wasn't evenly distributed. It was tilting a bit. So I lowered now this piece. So now you can see it lays flat. I also done some measurements. My bar here, my lever, is 1.90 meters, and I have measured the distance from the wall, and I know my weight. Now I have put this closer, 20 centimeters is the distance now to the center here. So now I should be able to put on 750 kilos, and I hope maybe that is enough to break it. So, new test. All right, so I managed to break it, and I can see what happened. I actually ripped off the bottom, so the glue didn't manage to hold it anymore. I also actually managed to break the plywood. That's a good news. Now I have made a marking exactly how far out I had to go before it broke apart. So now I'm going to do the same with the other model, the complex design. Yes, gotta remember the microphone. And I managed to break that as well. I actually had to put on more weight. I can measure now the length, and then I can calculate the kilos of force. So what happened here? I can see that what happened was I actually broke off this flange, or what to call it, where I have made the groove. Similar damage but I could put on more force actually with the complex model before it actually broke off the plywood itself. Maybe actually if I had not as deep groove, if my groove was a bit slimmer, maybe it would be stronger. No, I'm not sure really, because it was the remaining of the flange that broke off. Maybe I should have a deeper groove. Anyway, let me do some quick calculations. All right, I've done some tidying and I've done some calculations and I have the final results here. Before I reveal the result, it might look like the simple model. I tested that twice, while the complex model I only did once, but I just left that out from the video. So I did actually do the same testing on both the drawers. First one round where I had the distance about 35 centimeters away from the wall, the foot, the balancing foot, and then I put it closer. So they had, both the drawers had exactly the same pressure applied to them. And as you noticed, the simple design, the non-grooved one, it broke when I was moving 1 meter and 45 out on the lever. And when I calculate that, it was a pressure 580 kilos, 1,280 pounds was the pressure when it collapsed. While the grooved one, the complex model, I moved 1 meter and 75 centimeters out on the lever before it broke, and that was 700 kilos, 1,550 pounds pressure. That was a lot of numbers, sorry. The complex design could handle 20% more weight compared to the simple model. And it's not really important at all, is it? Because I will never load 500 to 700 kilos on my drawers anyway, will I? Okay, so what does it all mean? Let me give you a very short summary of my findings. The simple drawer, the benefit is exactly that it's simple to make. Much less cutting. And I think I'll save 10 minutes per drawer to cut out the pieces compared to the complex one. So that is very nice. 32 of the drawers I'm going to build this way, maybe all 56 of them. I'm not really sure yet, but I've spent a month on this project up until now. Spending 10 more minutes per drawer. I've calculated it to 4 or 5 hours. Okay, let's say 10 hours. Let's say it takes 10 more hours. It's not really, it's 1 day extra work. And a project that I will be working on for half a year, it doesn't really matter, does it? So, but that's anyway the benefit with the simple model. It's a bit simpler to build. Then it's the benefit of the complex model. It's a bit more simple to assemble and glue because I have the grooves. So when, yes, it's more complex to cut it out, the pieces, but then it's more easy to assemble and glue it. But the big benefit is that it is 20% stronger. It can hold 700 kilos instead of 580. And that is not really an issue. I'll never put that much load into the drawers anyway. So the conclusion is nothing matters. I can build any of those without any issue. So it's just deciding then on what to build. I have a favorite, but I would like to know what you would have done. So please let me know, put it in a comment. What version of the drawers would you have built? In my upcoming video, you'll probably see me building 56 drawers. Looking forward to see you back then. This is one of the bolts that hold the drawer. Can you see it if I'm rotating? Yeah, it's bent. So yeah, 700 kilos pressure.